Hi class! This pre-recorded lecture is about membrane filtration technique and heterotrophic plate count method. These are one of the methods when evaluating microbiological quality of water. So again, yung membrane filtration technique and heterotrophic plate count are used in drinking water. It can be used in your wastewater and recreational water, but series of dilutions should be done. Okay, so let us start. This is an overview of the membrane filtration technique. So very basic lang. You just have to do filtration process. Okay? Filtration process lang talaga. And then you incubate the culture media for 24 hours. This should be 24 hours class. And after incubation, you examine the growth of the colonies. So let us go with each of the procedure one by one. So the principle of the test class, the bacteria or the organisms are trapped in a membrane filter. We are using here a sterile membrane filter, and the bacteria or organisms are trapped because it has this 0.45 micrometers pore size, so that small can trap your bacteria. And then you have to filter 100 ml of sample, and this bacteria trapped in a sterile membrane filter, itong sterile membrane filter natin ay ipaplant natin sa culture medium. So, yung culture medium, again, na-discuss natin, let's recall, what are those? Indo-agar for total coliform, your FC agar for fecal coliform, and MTEC agar together with urea substrate for your E. coli detection. So again, i-recall nyo yung mga culture media. So we have to plant the sterile culture media into their respective or designated culture medium. And then you incubate for 24 hours and examine the growth of colonies after. So yung principle niya lang kas is via filtration. So membrane filtration technique is an effective and accepted technique for testing fluid samples for microbiological contamination. It involves less preparation than many traditional methods and is one of the few methods that will allow the isolation and enumeration of microorganisms. The membrane filtration technique also provides presence and absence information within 24 hours. Kasi class, if you notice, yung heterotrophic plate count, it will be after 48 hours. Yung multiple tube fermentation technique naman, the whole process will be around 3 to 4 days or 2 to 4 days. So, yung membrane filtration technique can already give you information within 24 hours. That is why drinking water can be done or processed through multiple tube fermentation technique. A lot of water testing laboratories, they still use multiple tube fermentation technique. Kaso nga, yung multiple tube fermentation technique requires a lot of preparation than your membrane filtration technique. This involves less preparation and way easier method than the other methods for water testing. These are the apparatus used. So we already start with the procedure. Ito yung mga apparatus. Again, let's recall, for fecal coliforms, they will grow at 44.5 degrees Celsius. So we need a water bath set at 44.5 degrees Celsius. And then an incubator set at 35 degrees Celsius for total coliforms. Miss, is it possible to use a dry incubator for fecal coliforms? Yes, it is possible to use to apply dry incubation for your fecal coliforms as long as it is set at 44.5 degree Celsius. But according to the Department of Health and as well as some standard methods for the examination of water and wastewater, it is best incubated at 44.5 degrees Celsius in a water bath. Kasi nga, mas madali yung transfer of heat from the from water to the medium than the dry recirculating incubator. So place fecal coliform culture plates in plastic bags or seal. Dapat of course, kung petri dishes, dapat naka-seal siya sa plastic bags with waterproof freezer tape to prevent leakage during submersion. Kasi nga, in membrane filtration technique, we are using plates in the process or in the method. Hindi siya pwede class na idiretso mo lang sa water bath. Make sure na naka-seal siya in a sterile plastic bag with waterproof freezer tape to prevent leakage during submersion. So, another apparatus that you will use in membrane filtration technique is the sterile magnetic funnels. This is not an ordinary funnel class. This is a sterile magnetic funnel. And then filter manifold and vacuum pump. So this is your filter manifold and this is your vacuum pump. It can be yung mga available na set. It could be yung single or it could be yung can be done by batch or group. So, mas madali itong by batch or by group. But again, most water testing laboratories, they still apply the traditional na multiple tube fermentation technique. Because in membrane filtration technique, you still need this apparatus, the membrane filter manifold and the vacuum pump. Another forceps and alcohol lamp, also sterile membrane filters with 0.45 micrometers pore size. This is not an ordinary filter. These are sterile membrane filters. And then sterile absorbent pads. This is for your E. coli detection. Remember class, yung sterile absorbent pads for E. coli detection. Then, of course, the culture media, yung Indo-agar for total coliform and fecal FC agar for fecal coliforms, and then MTEC agar for Escherichia coli detection, and also your urea broth for E. coli verification. Of course, you will need a lighter or matchsticks. So let us start. Number one, you assemble the filtration unit. Number two, you dip the membrane filter forceps in alcohol and sterilize by burning off in a flame. So of course, i-sterilize natin yung filter forceps. First, naka-immerse siya sa 70% alcohol. Tapos, i-burn natin over the flame. This is to provide optimum sterilization of the forceps. Third is you remove a sterile membrane filter from its pocket with the sterilized forceps. Make sure din na hindi ganon kainit yung forceps or else magisi ni siya. Okay? You handle the filter at the edge like this way but never near or at the center. So ganito siya. You remove it from the pocket and then you remove the funnel from the filtration unit with one hand and place the sterile membrane filter with the grid side up. Okay, yung grid side up over the porous plate of the filtration apparatus with the other hand. So, ganito siya ilagay, class. Actually, it looks very simple, but for beginners or those who are first-timers in the process, this is the most challenging part. Yung paglagay at especially yung pagkuha. Okay? So after you put on the funnel firmly, you shake the sample thoroughly 25 times. So that's 25 times. Yun talaga yung recommended na sa book, the standard methods for the examination of water and wastewater. You shake the sample thoroughly 25 times. That is why water samplers should collect water sample on until the neck portion only to give space to allow proper mixing of the sample to allow uniform distribution of the bacteria in water. So again, shake sample thoroughly 25 times and then you pour the sample into to the funnel. Yung volume should be 100 ml per parameter. So meaning 100 ml para kay total coliform at 100 ml naman para kay fecal coliform. The next is filtration is then accomplished by passing the sample through the filter under partial vacuum. So, ganun lang. I-on na natin at i-filter and we have to wait. So, again, waiting is part of the process in microbiology. So, hintayin na natin. And always remember, class, like this one, you always hit the mouth of the sample. Even the early layer flask, anything sa micro, dapat aseptic technique. So, dapat may always hitting in between. Okay? Then number 9, you after the filtration you switch off and then you remove the funnel, and that's the time you already remove the sterile membrane filter. So ito yung pinaka challenging na part, kasi if nahulog ito or na punit, it cannot be used already. You have to filter again. So it will be time consuming na naman. So after removing the membrane filter from the funnel, you place it or you put it on the surface of the culture medium. So Indo agar pag total coliform, and this one FC agar pag fecal coliform. You put it on the surface of the culture medium with a rolling motion to avoid the entrapment of air. So this is how you place it. This is also another challenging step. You have to do this quickly, and then dapat in a rolling motion. This is one of the technique. I really hope no we have a laboratory class for this so that we can perform. Then you apply it in a rolling motion, not just to avoid the entrapment of air. This is a technique para madali mo mahulog yung sterile membrane filter sa culture medium, and then eventually ma-close mo na agad. Okay? And lastly, a second membrane filter is then placed on the apparatus and the process is repeated. Of course, pag fecal coliform, ibang 100 ml na naman. And same with if E. coli, ibang 100 ml na naman. Okay? So that is why 100 ml per parameter. If maraming parameters, so yung bottle na ginagamit usually ng mga water testing laboratories are around 500 ml. Then incubate in inverted position at these temperatures. For fecal coliforms, 44.5 degrees Celsius for 24 plus minus 2 hours. And for total coliforms, that's 35 degrees Celsius for 24 plus minus 2 hours. For E. coli, dalawa yung temperature, 35 degrees Celsius for 2 hours. This is to rejuvenate stress bacteria. And then, i-continue mo sa 44.5 degrees Celsius for 22 hours. So, again, yung E. coli, this is a fecal coliform. So, it needs a higher temperature requirement. So, 44.5 for 22 hours. So after incubation, that's the time you remove the plates from the incubator and then you count the colonies. Yung E. coli class, using MTech agar, after examining the colonies, you will be able to after examining the colonies, if there is this positive presence of colonies, you have to apply to pour urea substrate. So you place absorbent pad. Dito na nagagamit yung sterile absorbent pad that I mentioned earlier for E. coli detection. You place the absorbent pad on the lid of the Petri dish. So you open yung Petri dish, yung absorbent pad nasa lid ng Petri dish, and then you add enough urea substrate doon sa culture media with the sterile membrane filter, enough na ma-immerse siya. Okay? And then you wait for 15 minutes, and after 15 minutes, you count the yellow or yellow-brown colonies with the aid of a fluorescent lamp or magnifying lens. E. coli class produces yellow or yellow-brown colonies. So this is how you verify total and fecal coliforms. I will not discuss further about this. ECMAG for E. coli. So ECMAG is a fluorogenic substrate test for your Escherichia coli. This can be also applied for the detection of Escherichia coli. But then, this is quiet or way expensive than the traditional methods. So again, ito ay fluorogenic substrate test for the detection of Escherichia coli. The presence of bright blue fluorescence is said to be positive for Escherichia coli. Excuse me. Next is this is the how you verify total and fecal coliforms. So ito yung mga alternative verification aside from this one. Alternative verification is through rapid test and commercial multi-test systems. So I'll not discuss this as well. So let's proceed. How you count fecal coliform colonies. Of course, after incubation, yung i-count lang natin sa FC medium are the various shades of blue colonies. Yung mga gray to cream colored are said to be non-coliform or non-fecal coliform colonies, do not count them. So again, we're up to the various shades of blue colonies lang kasi fecal coliforms lang yung ika-count natin. Okay? How do you count? You just really count every single colony. Okay? Once it is already hard to count, like very many or too numerous to count, that's the time you report it as greater than 200 colony forming unit per 100 ml. If there is no growth or zero growth, never report it as zero or no growth. That should be less than 1 colony forming unit per 100 ml. The same with total coliforms and E. coli detection. So this one for total coliforms, after incubation, you count only the pink to dark red colonies. It could be with the metallic surface chain or without the metallic surface chain. So count the both typical and non-typical colonies. Kasi yung typical colonies class are the pink to dark red with metallic surface chain. Yung atypical colonies, these are your dark red without the greenish metallic chain. So, you count again the pink to dark red colonies. Yung mga cream-colored or colorless colonies are considered non-coliforms. Do not also count them. Okay? For E. coli counting, after 15 minutes, I already discussed this, you count the yellow or yellow-brown colonies. So, this is how it looks like. E. coli colonies remain yellow after the urease test. Yellow colonies that are not E. coli turn pink to purple after the urease. So, ika-count lang natin are the yellow or yellow-brown colonies. The false positive total coliform test can be due to coliforms from natural aquatic flora like the Aeromonas, and false negative total coliform test might be due to high heterotrophic plate count. So this is how you calculate and report the results in membrane filtration technique. So it's colony forming unit per 100 ml, that is equal to colonies counted times 100 divided by the volume of sample filtered. Again, 100 ml lang din naman yung volume of sample filtered, so automatically count mo na lang yung colonies. Pag very insufficient talaga yung amount of sample, like sample 50 ml lang, that's the time you count the number of colonies, then you divide with the volume of sample, like for example, divided by 50 and then times 100. But then class dapat 100 ml jud yung sample ha, that is really the required volume of sample of water for testing. And lastly, I already discussed this, if zero or no growth in total fecal and E. coli detection using membrane filtration technique, it should be reported as less than 1 colony forming unit per 100 ml. If the colonies are not distinct enough for accurate counting, the report results as too numerous to count, TNTC, or confluent respectively. But the NTC class is already equal to greater than 200 colony forming unit per 100 ml. So this is one of the reason nga nung ang wastewater and recreational water should be suitable in multiple tube fermentation technique, because your membrane filtration technique is limited only until 200 colonies. So you will expect yung mga wastewater at recreational water, there will be high density of bacteria talaga, meaning greater than 200 colonies. So they cannot be really counted or useless lang pag nagme-membrane filtration technique tayo or nag-heterotrophic plate count unless you do series of dilutions, which could be hassle again. So, in reporting, again, yung standard values, this is the normal or accepted value, is less than 1 colonies or colony forming unit per 100 ml. These are the accepted methods of analysis. And the most commonly performed method is your membrane filtration technique. So this is from the Philippine National Standards for Drinking Water by the Department of Health, Administrative Order 2017. For E. coli, the same pa rin class, less than 1 pa rin yung standard value, meaning that is the standard value considered na past yung result. So lastly, total coliform rule requires not just total coliform, fecal coliform and E. coli as well, requires a maximum contaminant level goal of 0 for total and fecal coliforms in a 100 ml sample of drinking water, and this applies to all public water utilities. Meaning dapat 0 or no growth siya in order to pass. Okay, even just one colony forming unit per 100 ml, that is considered failed already. Okay? So, dapat 0 or no growth siya. But again, we do not report 0 or no growth. Report it as less than 1 colony forming unit per 100 ml. So, these are again the references that I am using for membrane filtration technique. Next, heterotrophic plate count method na tayo. Heterotrophic bacteria class are a broad group of pathogenic, non-pathogenic, and opportunistic bacteria. Its presence indicates the general biological condition of drinking water, meaning it can support data on the significance of coliform test results and efficiency of various water treatment processes. This one, water treatment processes. Most water providers na nag-undergo ng treatment, they will always submit for testing um, for HPC or heterotrophic plate count method testing. Okay? This is again very effective. I mean, this is highly tested yung HPC to know the efficiency of various water treatment processes. There are a lot of treatment processes class. Most commonly, yung mga water refilling stations, they have this RO or reverse osmosis. But that RO is always installed with UV light. May ibang clients that they will always insist na they have installed RO daw. So, dapat daw makapasar sila or limpyo ilang tubig. But then, RO class or reverse osmosis only removes chemical contaminants like metal ions and aqueous salts. It cannot remove bacteria at all unless UV light is installed. And of course, hindi din 100%. It depends upon the installation of the UV light. Okay? Yung spectrum of the UV light. And another is through chlorination. There are chlorine tablets that can be bought from stores or manufacturers. And of course, that also depends sa amount or concentration of the chlorine tablet with that to that of the volume of water. Okay? So kahit nag-undergo ng treatment, still they submit for testing, especially if mga water providers and food restaurants that should really submit for testing as one of their requirements for their business to operate. So, let's start. Ito yung mga apparatus na ginagamit for heterotrophic plate count. Incubator set at 35 degrees Celsius. So, isang temperature requirement lang, 35 degrees Celsius. And of course, yung autoclave. All the time, merong autoclave. Colony counter. This is already your Quebec colony counter. And a tally counter. We need sterile Petri dishes, but this time yung malaki na, the 100 millimeters by 15 millimeters. It could be the glass or the disposable plastic Petri dishes. Okay, then autoclavable micropipette set at 1,000 microliters. This is a different micropipette class from what you're using in clinical chemistry kasi autoclavable to, okay? Again, autoclavable micropipette. Kasi yung sa clinical chemistry, hindi man yan na-autoclave. This should, in microbiology, it should be an autoclavable micropipette. Of course, an alcohol lamp, lighter or matchsticks. Of course, plate count agar din. This is the culture medium that you will use in heterotrophic plate count method. Yung plate count agar class, it can actually, it can be used in your spread plate and pour plate method. And you will also need a spreader. Yung spreader is used, yung glass spreader is used in your spread plate method. And biosafety cabinet class 2 Sterile micropipette tips, that's 1,000 microliters or 1 ml as well. So let us start with the spread plate and pour plate method. So dalawang methods lang naman yung HPC. The difference is, in your spread plate method, you have to prepare the culture media first. You let it solidify. And then, you add 0.1 ml volume of water sample. After you rotate the sample counterclockwise and clockwise gently so that the sample is spread evenly over the surface of agar. But, I'm sorry, you have to spread the sample using a sterile glass spreader. Okay, let's go back. I am already confused with pour plate and spread plate. What I mentioned earlier is a pour plate method. So again, pag spread plate method class, you have to prepare the culture medium first. You let it solidify. Once it's solidified, you add 0.1 ml of sample, and then you spread evenly over the surface of agar using sterile glass spreader. Okay? And then after, you incubate 35 degrees Celsius for 48 hours, or that's 2 days. Of course, inverted position pa rin. And after incubation, you'll be able to observe surface colonies. Okay? In your pour plate method, this time you add the sample first, 1,000 microliters, or that's 1 ml of sample. And then you add the sterile molten agar into the inoculum or the sample of microorganism. And then you swirl it or rotate it clockwise and counterclockwise gently after you let it solidify. Once it's solidified, you incubate again at 35 degrees Celsius for 48 hours at inverted position. And after the incubation, you'll be able to observe subsurface colonies and surface colonies. Okay? So, your spread plate and pour plate method has its own advantages and disadvantages. Yung spread plate method class is useful for isolating aerobic microorganisms kasi nga exposed siya sa environment. So, there will be enough oxygen oxygen that will be acquired by the microorganisms. Next, cultures are never exposed to 45 degrees Celsius melted agar temperature because in spread plate method, you do not need to temper melted agar at 44 to 46 degrees Celsius, only in pour plate method. So this is an advantage because again, heat can cause destruction or it might kill other stress bacteria. Then one of its advantage as well, small volume of sample lang kasi 0.1 ml of sample lang. And then it can also observe colony morphology, whether it's raised, elevated, for example, or moist because nasa surface yung colonies. Okay? For its disadvantages, it allows the overgrowth of more colonies on the surface. So magka-crowded na, the tendency is it will be difficult to enumerate. Second, it does not allow the growth of facultative anaerobes and microaerophile microorganisms also grows slowly because nga nasa surface yung colonies. And lastly, contamination of the growth can occur. For your pour plate method, one of its advantages, it allows the growth of aerobes and anaerobes, facultative anaerobes, and microaerophile microorganisms because this time colonies can grow not just on the surface but also in the subsurface. Another is it is simple and easy to perform, and it is also suitable for detecting microorganisms present in low numbers and less risk of contamination, and it has also high accuracy. So between the two, pour plate method is highly recommended or highly suggested because of its high accuracy. So for its disadvantages, first, large volume of sample. Actually, 1,000 microliters or 1 ml, it's not really that large. I don't see it as a disadvantage. But of course, comparing it to spread plate method, mas lamang si spread plate method when it comes to the sample kasi mas maliit siya. And next, it cannot observe colony morphology. It can observe colony morphology But in spore plate method man gid class, most colonies grow within the agar or nasa subsurface siya. Maliit lang yung nag-grow on the surface, not like with spread plate method. So you cannot really observe colony morphology. Heating of agars can deteriorate sugar composition because again in pour plate method, pag may natira pa, especially if within 2 weeks yung expiry, you have to reheat it to be used again, and that can actually deteriorate sugar composition, and it can also cause heat shock to stress bacteria. Oxygen diffusion here is not sufficient for obligate aerobes. Obligate aerobes or aerobic microorganisms are best in your spread plate method because oxygen diffusion here is not sufficient in your pour plate method. So this is how it looks like. Ito yung spread plate method. If you notice, the colonies are nasa surface lang. For your spread plate method, the colonies are both on the surface and in the subsurface. But most of the time, nasa subsurface talaga. So for the procedure, for pour plate method, you prepare at least 2 replicate plates. So dalawa talaga for its precision for each volume of sample or dilution examined. For pour plate, you may use sterile glass, petri dishes, or the pre-sterilized disposable plastic petri dishes. Then you shake sample again thoroughly for 25 times. Optionally daw, you can use a mechanical shaker to shake samples or dilutions for 5 seconds. But then you can just shake the sample thoroughly for 25 times to ensure even distribution of bacteria. Before opening, of course, you disinfect the outside of the container with flame or the mouth of the sample bottle. And then you pipette 1,000 microliters or that's equivalent to 1 ml of water sample into the petri dishes prepared. Number three, you pour the culture medium, the plate count agar medium, then you mix counterclockwise and clockwise direction gently. You let the medium solidify around within 10 minutes and incubate at 35 degrees Celsius for 48 hours in an inverted position. After 2 days incubation, you count the colonies using an approved counting aid such as your dark field colony counter or your Quebec colony counter. Note that when colonies on duplicate plates and or consecutive dilutions are counted and results are average before being recorded. So dalawang plates ginagamit, you get the average. Then you round off the counts to two significant figures only when converting to colony forming units. So again, class, i-round off yung counts to two significant figures when converting to colony forming units. So do not let more than 20 minutes, preferably 10 minutes, elapse between starting pipetting and pouring the plates. Maintain melted medium in a water bath at 44 to 45 degrees Celsius until use, preferably no longer than 3 hours. Heat shock to bacteria from the transient exposure of the sample to 44 to 46 degrees Celsius agar may occur. So I already discussed this as well. So how do we count? Actually, class, when you use glass or sterile plastic petri dishes, there are different ways of counting. Let's have first the glass plates. For the glass plates, you count vertically and horizontally. You choose 6 squares vertically. You count the colonies sa 6 squares vertically and you also count the colonies sa 7 squares horizontally. Okay? Follow? So ito class, 6 squares, you will choose 6 squares. 6 consecutive squares vertically and 7 consecutive squares horizontally. Of course, pag dito, yung number 4 is dito na. Do not choose this kasi chosen na siya from your vertical squares. Okay, after counting, you multiply the total by 5. And that is already the number of colonies. So if no growth or zero, report it as less than 1.0 colony forming unit per ml. Per ml lang kasi 1 ml lang naman yung sample. Less than 1.0 kasi again, two significant figures tayo, okay? So this is how you count the glass plate. But for plastic or disposable plate, you count the colonies in 19 squares. This could be random squares as long as 19 squares. And then you multiply the sum of the number of colonies in 19 representative squares by 3. And after that, the unit will be EST, colony forming unit per ml. So if confluent yung growth class, or it will be very difficult not to count, report greater than 6,500 EST or estimate colony forming unit per ml for a glass plate. For plastic plate, greater than 5,700 EST or estimate colony forming unit per ml. So there are different ways again of counting using glass plate and plastic disposable Petri dishes. So you do not need to put EST or estimate if you can count the whole plate. And it is possible. Example, mga 48 lang or 32 colonies, makakount mo lang yan, class. Okay? But if you do not count, you do this procedure, that's the time you have to add EST before colony forming unit per ml, meaning it's a rough quantitative estimation of the number of colonies present in a water sample. And the standard values, again, based from the PNSDW or the Philippine National Standards for Drinking Water, is less than 500 colony forming unit per ml. If lapas nag 500, even 501, that is marked as failed. Okay? And these are the accepted methods of analysis. And the highly recommended method is pour plate method because of its high accuracy. So again, these are the references that I am using for heterotrophic plate count. Actually, same reference lang, class. This is really the Bible book of your water microbiology. And of course, along with the Philippine National Standards for Drinking Water by the Department of Health for of 2017. So that's all about membrane filtration technique and heterotrophic plate count. Thank you again for listening and have a great day, everyone.